Before we look at the laws, let me remind you what an index actually is. When we write a squared, we mean a times a. The index, which is the small number raised, tells us how many times to multiply the base by itself. A cubed means a times a times a, which is 3 lots of a. So the index is just a shorthand for repeated multiplication. These four laws tell us what happens when we combine expressions that have indices. You need all four of them for your A-level maths exam. Law 1 covers multiplication. If two terms share the same base, multiply them by adding the two indices. So a to the m times a to the n equals a to the m plus n. Think about why. A cubed times a squared is 3a's, then 2 more a's, which is 5a's in total. So that's just a to the fifth. 3 plus 2 equals 5, we are literally just counting. Law 2 is the reverse and covers division. Divide two terms with the same base by subtracting the bottom index from the top. A to the fifth divided by a squared cancels two a's, leaving 3. 5 minus 2 equals 3, and remember to always subtract the bottom from the top. Law 3 handles a power raised to another power. A bracket with an index inside and another index outside. Multiply the two indices together, a squared or cubed, means a squared times itself 3 times. Using law 1, 2 plus 2 plus 2 is 6, and 2 times 3 is also 6. Law 3 gets there in one step. Law 4 handles a product inside a bracket raised to a power. That outside power applies to every single factor inside. AB all to the n gives a to the n times b to the n. Remember, this only works when the terms inside are multiplied. If they are added or subtracted, you cannot split them. We will cover this shortly. Here we have y cubed multiplied by y to the fourth. First, let's check whether the bases match. And here they do. Both terms have base y, so we can use law 1 directly. So law 1 says multiplying with the same base means we add the indices. So we write y to the power of 3 plus 4. The common mistake is to multiply the indices, but multiplying is law 3, which only applies when a power is raised to another power. So here we're going to add. 3 plus 4 is 7, giving y to the 7th. Let's verify. Y cubed is 3y's, and y to the 4th is 4 more, so that's 7y's altogether. Here we have 12a to the 6th divided by 4a squared. When numbers and letters are mixed, we will deal with each part separately. We rewrite as 12 over 4 multiplied by a to the 6th over a squared. This separates the number part from the algebraic part, a technique which you'll use constantly. 12 divided by 4 is 3. For the a terms, the bases match, so law 2 applies. Subtract the index on the bottom from the index on the top, which gives us 6 minus 2. 6 minus 2 is 4, so a to the 4th, combining parts, 3a to the 4th. Always remember to write the number before the letter in the final answer. Law 3 covers the scenario where a power is raised to another power. Here we have x squared, and the entire bracket is raised to the power 3. Law 3 says to multiply the indices in this scenario, so we write x to the power 2 times 3. A common mix-up is to treat this scenario as law 1 by adding the powers, which is for multiplying two separate terms, which we do not have here. 2 times 3 is 6, giving x to the 6th. Check using law 1, x squared times x squared times x squared is 2 plus 2 plus 2, which is 6. Both lead to the same answer. Let's look at law 4 in action. We have 2x all cubed inside the bracket. 2 and x are multiplied, and there is a power of 3 outside. Law 4 says the outside power applies to every single factor inside. Raise each factor to the power 3 separately, and we get 2 cubed times x cubed. A very common mistake is forgetting the 2 and just writing x cubed. Every factor inside must get the power. Now look at the warning on the right. Law 4 only works because the terms inside are multiplied. If you had a plus b all cubed, you cannot write a cubed plus b cubed. That is one of the most common A-level errors. Addition or subtraction inside a bracket with a power must be expanded properly. 2 cubed is 8, so the final answer is 8x cubed. Let's take a look at a harder exam style question. 2 cubed times 4 to the 5th The bases are different here, 2 and 4, and law 1 only works when the bases match. A key insight we can use is that 4 is a power of 2. We can rewrite 4 as 2 squared. So let's replace 4 to the 5th with 2 squared all to the power 5. The second term now has a power raised to another power, which is exactly what law 3 handles. Using law 3 then on the second term, multiply 2 times 5 to get 10. So now we have 2 squared to the 5th becoming 2 to the 10th. Now both terms have base 2, and we can use law 1 directly. Now that we can add the indices directly, we get 3 plus 10, which equals 13. Our final answer is then 2 to the power of 13. Some other examples of rewriting a number in another base is 4 equaling 2 squared, 8 equaling 2 cubed, 9 equaling 3 squared, 16 equaling 2 to the 4, and 27 equaling 3 cubed. The index laws also work for negative and fractional powers. These are the 4 extra rules you need. A fractional index with a 1 on top means we need to root the number. The denominator tells you which root you need to take. So a to the 1 over m is the mth root of a. If the top of the fraction on the index is not a 1, you get a root and a power combined. The denominator is the root and the numerator is the power. A negative index means 1 divided by the positive version. It does not make the expression negative, it instead flips it into a fraction. And anything to the power of 0 just equals 1. Even an expression like 100 to the power of 0 is still just 1. This follows from law 2, as if we divide any term by itself, you subtract equal indices, leaving 0 on the index, which must equal 1 by definition. Okay, let's look at 27 to the power 1/3. The index is a fraction with 1 on top, so we are taking a root. The denominator 3 tells us it is the cube root we are looking for. So 27 to the 1/3 is the cube root of 27. Whenever the numerator is 1, just convert it into a root straight away. The cube root of 27 is 3 because 3 times 3 times 3 equals 27. Below are some examples of perfect cubes, such as 1, 8, 27, 64, and 125. Now let's look at 16 to the minus 3 over 2. Here we have two things going on at once, a negative index and a fractional index. Let's always deal with the negative sign first. The negative index becomes 1 over 16 to the positive 3 over 2. Now handle the fractional index. The denominator is the root and the numerator is the power. The denominator is 2, so we take the square root of 16. The numerator is 3, so we cube that result. Always do the root first, it keeps the numbers smaller. So if we take the square root of 16, we'll get 4, and 4 cubed is 64. This means that our final answer is just 1 over 64. Okay, that's all for this video. If you feel like I've missed any examples or you'd like me to cover another scenario, feel free to drop a comment below, and thanks for watching. If this helped, please subscribe. It really does help the channel, and I'll see you in the next one.